بیوگرافی خیلی ریزی خلاصه‌ای بگم، چون خودشون ایشون هم میخوان در مورد بیوگرافیش هم صحبت بکنن، یه خورده نمیخوام اسپویلش بکنم. Dr. Rezvani was born in Kashan. He went to Tehran University for his bachelor's in biology and a master's in teaching biology. He came to the US in 1976, and he's going to tell you more about his academic career and development. He's currently a professor of psychiatry and behavioral sciences at the Duke Medical Center, the Duke University Medical Center. His talk today is going to be about addiction as a brain disease, as well as factors in its manifestations and treatment. آقای دکتر رزوانی بفرمایید.
I have to speak English, I guess, right?
الان میتونید قاطی هم صحبت بکنید بعضی جاها، فارسی انگلیش با هم.
اوکی. سلام و درود خدمت تمام دوستان. لطف کردید در این موقع تشریف آوردید. من سعی میکنم که خیلی خلاصه صحبت کنم که حدود نیم ساعت تموم بشه. از لیلا جون و شقایق خیلی تشکر میکنم برای زحماتی که میکشن برای این کامیونیتی. خیلی زحمت میکشن، تشکر میکنم ازشون. عرض کنم که موضوع سخنرانی من هست Addiction as a Brain Disease و خلاصه به اصطلاح جرنیم هم که ایشون گفتن. من در دهکده به نام بیتگل در کاشان متولد شدم. فقط یادم هستش که اون موقع هنوز ما هنوز برق نداشتیم. And then I was 8 years old that we moved to Tehran, and then I attended Darul High School. I got my science diploma, natural science diploma from Darul, and then went to Tehran University. I got my BS in biology, and then we came to the United States. My brother-in-law was in Missouri as a student, so we went to Missouri. I attended the University of Central Missouri. I got another degree, another master's degree in biology. Oh, I forgot to tell, in Tehran also I received a master's degree in teaching biology. After finishing my master's degree in Missouri, I went to University of Illinois for PhD, Department of Physiology. I received a PhD in physiology, and my thesis was about endorphin. At that time, endorphin was very hot because it was just discovered, endogenous opioids in the brain. So I did my thesis on the effect of endorphin in temperature regulation using rabbits as an animal model. After that, I went to University of North Carolina in Chapel Hill for my postdoc. I attended I was in a lab that my mentor had 3 lines of research. One was eating behavior. The other one was temperature regulation, and the third one was alcohol. So it was very interesting. First, I did some temperature regulation because my thesis was about that and for my PhD. And then being exposed to that lab, I became interested in alcohol research and addiction. And then so I did some research on that. I was very amazed to see that some animals actually drink alcohol. So that was really very interesting to me. And then I stayed there for 15 years doing research, and also I designed a course as an elective course for medical students. The course was about addiction and substance abuse. And then also I was teaching a course, the same course for social workers in the School of Social Work at night. I really loved it. I loved teaching because it was the interaction between the students and myself. I learned a lot, and that was really good. And then about 22 years ago, I moved to Duke University. Duke University, for those of you who don't know, is very close to Chapel Hill. So we didn't have to really move. You know, it was about maybe 12 miles from each other. So I went to Duke University, a department of psychiatry, and then I was working with another colleague, Dr. Ed Levin. We shared the lab together, and he was interested in nicotine addiction, and he was doing a lot of nicotine work. He has published a lot. And when I joined Duke University, I introduced alcohol research to that lab. So we did a lot of alcohol work, and then nicotine, and then other drugs like cocaine, and then amphetamines, and so on. So that was my academic journey. Now still I'm at Duke University, and then here is why addiction is so important. I want to show you some data here to see the magnitude of the effect of addiction to the society. This is the actual cause of death in the United States in 1 year. We lose about 430,000 people to tobacco, for cancer and cardiovascular diseases and so on. Alcohol, about 90,000 people die. And opioid overdose is about 70,000, especially in a rural area. Opioid addiction is a major health problem. And I wanted to compare these problems with some other diseases. Heart disease, we lose about 600,000. For cancer, we lose about 600,000 people every year. So if you combine tobacco, alcohol, and opioid, is almost more than 600,000 people a year. And just to give you a reference, during the Vietnam War, which was a 10 years war, it was a very unjust war. America lost 56,000, about 58,000, I think, for 10 years. Just imagine 58,000, 10 years, more than 500,000 a year now. And we are still talking about the Vietnam War. We write books and articles and so on, and we should, but we really do not talk much, or the society do not talk much about addiction as a major health problem. What is addiction? Addiction is defined as a chronic relapsing brain disease that is characterized by compulsive drug use despite very bad harmful consequences. Alcohol, for example, alcohol has been around for thousands of years. Fermented honey jars from Iran, our country, and China have been discovered from 10,000 years ago. So they were using alcohol then, even then. And in 700 AD, alcohol distillation invented by Persian physicians named Zakaria Razi. So, so Iranians had a lot to do with alcohol and drinking. And alcohol has been around, as I said, for thousands of years in every society. This picture shows that the painting from the Khaytes tomb in Egypt, which goes back to 4,000 years ago, shows that, a guest being carried away from a banquet after drinking too much wine, right? So as you probably know, experience it, people drink when they are sad, people drink when they are happy. So it's as a part of almost every culture. Okay, what factor do you think contribute to development of addiction? There are three major factors. One is the user or the individual. Here on the left screen, social status of the individual, the age, risk-taking, psychiatric status, and genetic. All right. The other factor is the drug itself, the potency of the drug, the cost of the drug, the side effect of the drug. And the other factor is environment, peer pressure, parents, family attitudes, and opportunity. So interaction of these factors leads to the manifestation of addiction. If we remove any of these factors, we don't have addiction. If we remove drugs, we don't have addiction. If we remove the individual, we don't have addiction. So these three factors have to come together to make a person to become addict. And for example, for drug, the cost, for example, if the cost is too high, we have less addiction. This has been shown in New York several years ago. They decided to increase the tax for cigarette, and then they raised it very, very, very high, and the nicotine addictions went down significantly. So just remember these factors when you're talking about addiction. Addiction usually begins with a voluntary behavior. No one puts a gun on someone's head and say, drink or smoke. Thus, addicts should be able quit by force of will. A lot of people believe in that. They say, well, you start voluntarily, so you have to be able to start by force of will. But it's not that simple. When it's come to addiction, it's not simple. I have talked to many recovering drug addicts. Believe me, is not very easy. So we have a concept, it's called hijacked brain. When someone is hijacked, as you know, as you heard, when someone is hijacked, the person is not in control anymore, right? So the concept of the hijacked brain came up about maybe 25 years ago or 30 years ago. So the brain is hijacked, right? So this is the structure of the brain, as all of you know. We have the different lobes, and there are billions of neurons are interacting with each other, talking to each other, stimulating each other, inhibiting each other. And each part has a special role, especially the frontal lobe, when it comes to addiction, plays a major role, because the frontal lobe is the is the CEO or executive chairman of the whole system. Frontal lobe is in charge of executive function, is in charge of the making decision and judgment. So it's very, very important part of the brain. Probably you have seen this picture in your psychology book. This is the story of a person by the name of Finis Gage. He was a worker and working in a train station and a railroad, and one day a rod, an iron rod, was thrown to his face and went through his left eye and then came out from the brain. And fortunately, he survived. But he was not the same person anymore. Before that accident, he was very normal. He was making good decisions. He was a good judgment. He was a good citizen. But after that, although he survived, he was making very bad decisions. He was a different person. So that made a lot of science to think that probably didn't have anything to do with his eye, but maybe it has to do with the frontal lobe, and which was the truth. So, and then it has been shown in the brain of addicts, there is a reduced activity in prefrontal cortex, the frontal lobe, where rational thoughts can override impulsive behavior. We have a lot of impulsive behavior. There are a lot of things that we always want to do, but we don't do it. The reason we don't do it because the frontal lobe tells the reptilian brain down there, say, don't do it, right? But in drug addict, the frontal cortex is damaged, so they cannot control their impulse. So this is something that a lot of people don't recognize that, and they think, well, you started voluntarily, well, stop drinking or stop smoking. And what factors, why people take the drug in the first place? Peer pressure, curiosity, family culture, environment, genetics. A lot of people take drug for self-medication, especially they have a comorbidity, to feel good, to escape reality, and there are other factors too. This is an ad from a cigarette company from many, many years ago. It says, reward yourself. Reward yourself. There's some elements of truth to that ad, because when you take drug, when you smoke, you feel good, right? So that takes us to a pathway in the brain, the reward pathway or the pleasure pathway, which is briefly extends from the ventral tegmental area, the red part in the middle, and extends to the nucleus accumbens and goes to the frontal cortex. This is a dopaminergic pathway. So when the VTA or ventral tegmental area is stimulated by electricity, by eating, drinking, taking drugs, you stimulate that area, ventral tegmental area, and dopamine is released in the nucleus accumbens and the frontal lobe, and it feels good. We have natural pleasure. Why Mother Nature designed that pathway? That pathway is necessary for survival, because if eating was not pleasant, we would not eat. If sexual activity would not be pleasant, we would not do it, so we would not reproduce, and the species would go away. So this pathway is for natural pleasant, like eating, drinking, and reproduction, all right? But for those activities, every time that we do those things, we get about maybe 50% or 100% increase in dopamine, But when we take drugs like methamphetamine, instead of 100%, we get 1,000 times increase in dopamine. When we take cocaine, it's like 400 times. So so actually human beings have been abused that system by taking drugs. So that's so dopaminergic system. The dopaminergic pathway in that area is called the pleasure pathway, which is involved in the reward, pleasure, also compulsion. Also, we have serotonergic system, serotonergic pathway involved in that. I'll get to it in a few seconds. Different drugs have different effects, but the end result is the same, pretty much the same. End result is increasing dopamine in the synaptic cleft. Synapse is between two neurons, right? Between the postsynaptic neuron and presynaptic neuron. Like cocaine, when we smoke cocaine, we use cocaine. Cocaine gets to the brain and goes to the synaptic cleft and blocks the reuptake of dopamine from the synapse. Those dopamine stays in the synapse for a longer period of time. It stimulates the postsynaptic neuron, so we feel good. So cocaine blocks reuptake. Amphetamine does not block the reuptake, but increases dopamine release. So again, the end result is more dopamine in the synapse. Cigarette, when we smoke, there are about maybe 7,000 chemicals in tobacco. Okay, and a lot of them have a very, very, very bad effect. One compound in cigarette is MAO, is monoamine oxidase. Monoamine oxidase, what it does, it blocks the dopamine metabolism or breakdown. So the dopamine in the synapse cannot be metabolized, so it stays for a longer period of time. So the end result of all of these drugs is more dopamine in the synapse, and it feels good. Okay, here is some data from the animals. This is shows the increase in dopamine in nucleus accumbens. But when we eat, is about 150% increase. For the sexual activity is about 200. But look at the drugs. For amphetamine is 1,000%. For cocaine is about 300,000. For nicotine is about 200,000. For morphine is about 200. So, but all of these increase dopamine in the synapse in nucleus accumbens, but at different with different magnitudes. Positive hedonic effect of drug consumption increases dopamine, also increases opioids in the brain, endorphin and serotonin and GABA. When the person goes through withdrawal, all of these, we have the reduced, like dopamine is reduced, opioid peptides is reduced, serotonin goes down and GABA goes down, and the result is dysphoria and anxiety and panic attack. And so that's why withdrawal with drugs can be very, very, very unpleasant. And for alcohol, actually it doesn't happen every day, but can kill a person. But for the other drugs, is very, very, very bad. Addiction does not discriminate. Okay, here is the genius Ernest Hemingway, was an alcoholic. Here is First Lady Betty Ford. She was an alcoholic. And Robin Williams, a very, very talented artist who killed himself, and he was a drug addict, okay? So what is a disease? Disease, by definition, this is from Donald's Medical Dictionary, says any deviation from or interruption of the normal structure, anatomy, or function, physiology, any part of organ or system or combination that's manifested by characteristic set of symptoms and signs, and whose etiology, pathology, and prognosis may be known or unknown. It's called a disease, right? So there is a structure damage, function damage, and then you have signs and symptoms. If I want to summarize, simplify it, is like this. We have an organ, the organ has a defect, and we have symptoms. Example, diabetes. Organ is pancreas, defect is cell death, symptoms, high blood sugar is a disease. There's no question. No one says diabetes is not a disease, right? Look at alcohol or addiction. Addiction, the main organ is the brain, right? The main organ is the brain, and the defect is change in structure and function. We have a lot of evidence from brain scan that people who use a lot of drugs, there's a change, a structural change and physiological change in their brain, especially frontal lobe. Okay, so we have an organ, we have a defect. Symptoms. What are the symptoms? Craving, loss of control, bad judgment, confusion, low emotion, and etc. So exactly like diabetes, addiction falls in the same model. So it is to me it is, and also met a lot of people who are working in this area now is a disease. And as I said, is when we are talking about this disease, we have to consider all of these factors: the individual, especially the genetic background of the person, the potency of the drug, and environment. Genetic basis of alcoholism, I want to say a few words about that because we have a lot of data, a lot of literature on that. Okay, there are the evidence for genetic aspect of alcoholism comes from human studies and from animal studies. From human studies, we have 3 lines of research: family studies, twin studies, and adoption studies. Family studies, probably you have heard that alcoholism runs in the family. So there's a lot of information. For example, if the great-grandfather was an alcoholic and the father was an alcoholic, and some of the children might be an alcoholic. Not every children, all right, but runs in the family. There's a lot of literature on that. You can check on the PubMed. And the twin studies very interesting. Also has been done in human. And then look at the identical twins and fraternal twins. Identical twins, as you know, they have exactly the same genome, right? And fraternal twins have the 50% similarities. In identical twins, it has been shown that if one of the twins become an alcoholic, there is about 60% chance that the other one would be alcoholic too. Now the question is, if they have exactly the same genome, why 60% and why not 100%? The reason is because, again, environment has a role to play, all right? So that's why, but still 60% is a very high number. And the fraternal twin is much less. If one of them has become alcoholic, there is a much less chance that the other one would become alcoholic compared with the identical twins. Adoption studies, the children have been adopted away from their biological parents at very early age, and then it has been shown, and then they were raised by non-biological, non-alcoholic parents. It has been shown that if their biological parents had problems with alcoholism, there's a high chance that the children, even not being exposed to their parents, become alcoholic. So these are very strong evidence from human. And from animal studies, we have more data actually, because it's very easy to work with animals than human. There are several lines of animals. Rats, it's called selectively bred lines. These rats, like alcohol preferring rats, high alcohol accepting rats, and so on. Usually, if you get 100 rats and test them for alcohol drinking, 95% of them would taste alcohol and say, well, I don't like it. They would not drink it. But you know what? You might end up with 5% of alcohol, 5% of the rats that would like alcohol. And if you take those 5 rats and mate them together and then breed them, and then test their offspring again, and then select those who drink, and then mate them together again. But after 15 or 20 generations, you come up with a line of rats that they drink alcohol. They drink alcohol a significant amount. their preference for alcohol is maybe 80% and 90%. So those rats, there's a lot of evidence, again, the literature, you can check out the PubMed. They have shown that these rats have serotonin deficiency, they have dopamine deficiency, and if you challenge them with a serotonergic compound or dopaminergic compound, you can reduce their alcohol craving. So, so that again shows that the genetic aspect. So that is selectively bred. The other one is random mutations. Random mutations have, as you know, it happened by Mother Nature for some reason. And then there's a line of rats, actually, I found out about maybe 30 years ago. Someone told me there's a line of rat in New York Health Department that they are using it for platelet studies. Platelet is a source of serotonin in the blood, as you know. And she told me that these rats have a genetic serotonin deficiency, both in the periphery and in the central nervous system. And at that time, there was a lot of, there was a hypothesis that serotonin is involved in depression, of course, and also in alcoholism. So I thought, you know, if these rats have serotonin deficiency, if genetic serotonin deficiency, then they should drink. So I got some of these rats. At that time, I was at the UNC Chapel Hill. I got some of those rats and we test them for alcohol. How you test them is very easy. You put them in a cage, you give them 2 bottles. One bottle is water and the other bottle is alcohol, 10%, 15% alcohol with no flavor. And the rat has the choice to choose between these two. And boom, we saw that, well, these rats are really, really like alcohol. So they drink alcohol a lot because of the serotonin deficiency. And when we challenge them with a serotonergic compound like fenfluramine, their alcohol intake went down. I'll show you a graph in a second. The other line of evidence is from knockout and knock-in animals. You know, if you're suspecting a particular gene is involved, you can introduce that gene into an animal to see what happened, or if you can, or you can remove that gene to see what happens. This is another line of research. There's a lot of mice actually, knockout mouse and knock-in mice for these studies. Okay, this is the fawn-hooded rats that I mentioned. They have genetic serotonin deficiencies, both in the periphery and the central nervous system, and they drink alcohol. And also, since serotonergic is involved in depression, I thought, you know, they might be depressed too. So we tested for depression, and yes, they showed they have depressive tendencies. How do you test for depression in rats? Of course, you cannot tell them, how do you feel today? They would not say, they would not answer. But it's very easy, actually. You get a tank of water, a tap water, and just put the rats in it for 5 minutes. Usually rats, if they're normal, they swim. They don't get drowned or nothing happens to them. They swim if they're normal. And if they have depression, during 5 minutes, you know, they swim maybe 1 minute, and then after that, they just stay immobile. So by measuring immobility, you can tell if the rat is depressed or not. Actually, this test has been used by pharmaceutical companies for testing drugs against depression. So again, this showed that serotonin is involved both in alcohol and depression. This is the data for fawn-hooded rats. You know, with saline, they are drinking about 6 grams per kilogram alcohol. And then if you inject them with different doses of fenfluramine, which is a serotonergic compound, you see the alcohol consumption goes down significantly. But very interesting, the water goes up. So the total fluid doesn't change. So the animal simply switches from a water bottle, from alcohol bottle to water bottle, which is very interesting. And this, we have been published this, okay. So one thing I want to mention that, you know, genetic of alcoholism is very, very, very complex because there are many genes are involved. Some of them have a main effect, some of them have a small effect. The difference between this magnificent dog and the little cute puppy, there's only one gene. But for alcoholism, it's not easy. So when we are talking about behavior, like, you know, alcoholism, that's why it's so difficult to deal with it. Okay, pharmacotherapy for addiction. We use pharmacotherapy for a lot of, for almost every diseases, for why not for addiction. We have tested, I mean, there's no time to go over everything. We have tested a lot of drugs for reducing alcohol consumption. And then one of them is a specific nicotinic cholinergic alpha-4 beta-2 receptor, which have shown that reduces both alcohol and nicotine, as well as cocaine. This is the structure, and then we used selectively bred alcohol-preferring rats, two by their choice, water and alcohol, and we tested acute dose and also chronic and also post-deprivation. You know, post-deprivation is when they develop the dependence, and then we remove them from alcohol for 2 or 3 days, and then we test them again. And here is the data that showed Sazatide. The compound is called Sazatidine A. Sazatidine A developed in Georgetown University. They sent it to us. We tested. Dose dependently reduces alcohol consumption at 4 hours after alcohol exposure and 24 hours after exposure. And it was published in Psychopharmacology. And then, in summary, it reduced, we test, I don't have time to show all of the data, but trust me, yeah, both acutely and chronically it reduces alcohol consumption, and also following post-deprivation. Yeah, and then my colleague was interested in nicotine self-administration, so we did a nicotine self-administration test. This is an operant box. The box has two levers, and the animal, we train the animal to test one of the lever, which is associated with the light. Every time that presses the lever, it gets a pellet for food. And then after learning this, we do a surgery on them. We put a catheter in the jugular vein, and then we put them in the box, and the catheter is connected to a pump. The pump has nicotine in it. It can be cocaine or any drug. And every time that the animal presses the lever, gets an infusion of the drug, nicotine. If the drug is rewarding, the animal is going to continue to do it. So this is a standard test, a lot of literature on that technology. And then when they become dependent on nicotine, then we can inject, before putting in the box, we can inject them with the drug to see if the drug can reduce nicotine self-administration. We show that when we inject them with Sazatidine, you see that a significant reduction for 10 days. And it was published again in the Journal of Pharmacology and Experimental Therapeutics. So summary, that compound also reduces nicotine self-administration. And the conclusion. So development of a novel drug with nicotinic properties may offer an important avenue for the treatment of addiction and attentional performance. And also we look at the effect of this drug on sustained attention, and it helped to improve sustained attention as well. So future directions, exploring combination pharmacotherapy. Combination pharmacotherapy is very, very useful because you can combine 2 different drugs or 3 different drugs. And the beauty is that, you know, you can use these drugs at the lower dose and for each one, so there's not much side effects. And then the other line is exploring the genetic contribution, and then exploring the effect of these and other drugs on comorbidity, because a lot of drug addicts have comorbidity with other mental disorders like anxiety, depression, and so on. So we should be very interesting to look at these drugs on comorbidity. And lately, we are also looking at, I don't have time to talk about this, effect of marijuana, paternal marijuana on offspring. We have a lot of data on the effect of maternal mother using THC or marijuana on offspring, on babies, but unfortunately, we do not have much data on the effect of paternal. So that's a new line of research, and we are looking at that. And so far, we have shown that yes, even if with a small dose of THC used by fodder rats, we see some effect on offspring, like in anxiety and so on. We have published, I think, one paper so far. These are my colleagues that helped, Dr. Levin, Duke, Dr. Keller from Georgetown University, and Dr. Zhao. They designed actually the sazatidine and sent it to us. Dr. Rose and Dr. Lee and so on from different universities. So collaboration was a major factor in our success, and I acknowledge that. And thank you so much for your patience and attendance.